So I'm going to
Well,
start.
what about a German train?
A German train? I don't know. I haven't taken German trains as much as I've taken like the Shinkansen and even the local trains. It's like, it's 3:02 and boom, the train's there or whatever. We're straight on the hour at 3 o'clock. Literally, you guys have 3 days before this thing is due. And actually less than that, 2 days and 23 hours and 59 minutes. So let's make sure that gets right. I'm going to wait a couple minutes before we get started. We had a couple video sessions last week. One was the idea of using a high altitude balloon as your vehicle. So that was kind of cool. And we've done a number of those, Tony and I and our crew. Oh, wow. Between the mid altitude and high altitude, we probably have gotten 75 or close to 80 balloon launches up in the last few years. So those are a heck of a lot of fun. So I've got a video link I'll share with you guys since you're all registered to that. That was on Tuesday. And on Thursday, we had Professor Twiggs, the co-inventor of the modern CubeSat. He was on, he's a character. And he was there with Dwayne as well, talking about deep space CubeSats and really kind of more mission readiness. And today, which I'll start up in just a minute here, is really going through the 5-step rubric that the Department of Education is asking from us if you're submitting something. And I'll reiterate, I'm not a judge, nor is Tony in this. And so we're going to try to stay pretty open and address things as we see them. Ultimately, the judges will judge the way they do. But there are 5 components to this competition. And what I'll do here is I imagine you guys have probably already been working on this, but just for simplicity and for anyone that's reading this after the fact, I will just share my screen so you can kind of see the challenge itself. And one important thing I do want to stress is eligibility. So I've talked to a couple schools that were really excited about the program, but they were like a middle school, and so they actually didn't qualify. That disappointed the teacher and some of the students, but that was okay because we talked about what if this inspired you to go do something, well, you should just go do it. Don't wait for this grant to happen, right? And they're really affordable ways to keep this going forward if that's something you're really excited about. So number one, regardless of the outcome of your proposal, if you're really interested in this, you try to find ways to make it happen, and you'd be surprised at how affordable you can make it. But it does, you do need to be in a school that's part of the Perkins 5 funding, right? And so either charter or public school. So as long as you have that, you're in pretty good order. I've had one school that had program at the community college, and they were Perkins qualified. So they're right now, they were scrambling to get that worked out where their program, even though it was run at their high school, could be attributed to the college in which they were taking courses anyway. And so they're kind of working through that paperwork. So there are ways to make it happen, but with just 3 days left, pretty much I'm expecting that you guys are Perkins qualified. And so with that, we might have another couple of folks popping in, but let me just kind of go through this. The phase 1, as I think if anyone that's read through it knows, it's really just about some writing. And of course, it's more than that because you're going to really want to think about what your mission is and why you even want to do that. And so I think that's going to need to be the underpinning of all the things. If you look at your rubric, there are 5 components, but at the end of the day, why are you putting something in orbit, right? Why are you thinking about maybe running a proto satellite at altitude, whether it's a high altitude balloon or perhaps a sounding rocket on like a Blue Origin mission or a NASA sounding rocket or what have you, or even just going to a local rocket club and launching something with an HPR motor, high power rocket motor. And so really what's driving you, I think, needs to come through the thread in all these different components, these different pillars, if you will, of the 5 rubrics. And so what is the high vision motivation? There are a lot of things you can investigate from a science perspective, and we can talk about that on the back end if you just want to, I think, a little more philosophically. But Earth observation is a natural thing that folks want to do, and whether they're in orbit or in the atmosphere. But really think of something thematic that you can thread through these if you can find a way to do that. I think it'll really get a couple extra points in there. You'll have cohesiveness, and you also have a real mission. I mean, regardless of the outcome of your proposal, at the end of the day, what you really want to do is kind of look at it and go, wow, this is a real mission. I can just, go out and do a little fundraising, a couple bake sales, and I've got my helium gas for my balloon or whatever it is that you're trying to do at the first phase. And if you really do want to take it all the way up to putting something in orbit, If you're juniors already, you're probably going to be in college by the time you'll be able to get it in orbit with all the factors that are involved. But if you're just a freshman or sophomore, or if you're a teacher or an administrator in your school, make a plan, a 5-year plan, and you can get something in orbit. We're lucky. We put things in orbit in a little more, I guess, simple way. We get rides on like a SpaceX rocket or, a Cygnus resupply mission. And we load things up on the space station. So we rely on the International Space Station to provide our research. So we've got the telemetry already set up, the power is all set up, and data, and so that makes it easy. What's also cool in terms of thinking about these cube labs, and something that goes to space is like a 10-centimeter cube, right? It's just like, well, what do you know? It's just like your CubeSat, except now this is like intermodal transportation for research. And when you send something to the space station, my goodness, you can bring it home again, which, unlike your satellite, once you get it up there, you're doing your research remotely, and then whatever you've gained, and then you burn it up after about a year or so. But let me get through the 5 parts here of your rubric. And by all means, if you've got a question during this, just pop it into chat, and I'll probably finish before the hour because it's not really that difficult, but just want to make sure everyone's thinking about how they're going to rank. So number 1, really vision, right? And whether it's in the front, in the back, or you've read it throughout the rubric, really think about why you're doing this and what you're bringing the team together to do, all right? So the first one is community engagement. So you might have a half a dozen of your colleagues there in high school, and you've got a club or you've got a class, and you want to do this project, and that's great. What the U.S. Department of Education wants to see is, what are you doing that might be added benefit to your community in terms of outreach? Now, one can think about it like fundraising. Oh, I'm going to go out and talk to my auto dealer because I want to raise some money. Well, that's community engagement, but that's maybe not as deep of engagement as you could make it. What if you could do some kind of observation or some other kind of data that could be acquired through your CubeSat mission? Could it benefit your community? Whether you're in urban, suburban, or rural area, you probably have some unique things in your environment that you can begin thinking about, whether it's a heavy polluter or traffic flow or migration of animals or some such. You start thinking about what's possible in the context of your community. Maybe you've got some nonprofits, if you haven't already reached out to them, or some other large philanthropic groups, or maybe a large corporation in which you want to say and go to them, because they also could be a benefactor if you think about it, regardless of the outcome of this proposal. How do I involve my community, and not just like my high school, and just not like the PTA or other folks that are naturally around your organization? That takes a little entrepreneurialism, and I'm kind of open for discussions if anyone has any ideas. I think we can get pretty clever if you've got an interesting scenario where you want to chat offline about how you can involve your community. I'm more than happy to schedule a call with you between now and Friday and kind of work through some of those ideas. Because if you put something in place that's solid, again, regardless of the proposal outcome, you now have this working program that you can, just like the football team goes out to and the band goes out and finds ways to engage. You can, but it's not just a financial engagement. You're thinking about a science or for engineering engagement. That's kind of cool. You have a local airport, for example, that you can reach out to. And those small community airports usually can be much more accessible than, say, like an urban center. But you'd be surprised. Do you have a military base nearby? Could they provide some kind of support or outreach? Do you have any other programs that might think about after school? Can you take what you're doing at your high school and teach a middle school? Right? Wow, that's kind of interesting. And now you've kind of worked with community outside the school in kind of an extended way. So community engagement, 1/5 of your score here, right? Super important. So let's not forget that. Your CTE connection. Now this is going to be unique to each program that you guys have got running. Invariably, we see things like the maker spaces, right? And or computer science. So leading with the programming. So the most important thing here is whatever framework you're currently working in, find a way to make that connection, to make it authentic. Forcing two things together that don't really fit is not a good idea. So if you can't find that most immediate connection, it might be good to kind of maybe take a step back. Again, this is all kind of personal opinion. I don't have any judgment in the scoring at all on these things. but your connection and what you do. So if you've got a lot of milling equipment, like you got CNC mills and 3D printers, got laser cutters, you probably want to talk those up and talk about prototyping and talk about your workspace. If you don't have any of those things, maybe you've got a computer-aided design and you guys have got a really agile format that's set up for that. Talk that up. Talk about the design component of that. If you're in robotics competitions or something along those lines, and that's a core part of your CTE program, find a way to take components out of what you've already learned in, whether it's FIRST Robotics or any of these other robotics competitions, and get elements of that and introduce it. What we learned in FIRST Robotics, we're bringing to the Cubesat, and these are the reasons why, right? Super important you make that connection, right? Again, it's going to be like 1/5 of your score. And I'd be really interested to hear any unique perspectives any team might have in that respect, whether here on this call or separately. But so community engagement, again, really critical, not just looking for money, and your Cte connection, authentically tying to the programs you're currently using at your school. Learning outcomes. So I think probably the one way you can approach this, I'm not going to say it's the best way, but one way you could approach this is through the lens of the students as learners. So it could be from a teacher's perspective, but I think coming from students, for other students that are on and for the teachers that are listening, having a student voice is really powerful, because, you know, it's really easy for the adults to kind of be in the room and say, well, let me show you how that's done. The hardest thing sometimes, especially if we kind of know what's going on, is to actually take a step back and say, well, I don't know, what do you think? And let the students figure it out. And so when you think about learning outcomes, a thing you can consider while you're kind of looking at the kind of master plan, if it's a teacher, this is the learning outcomes. I need to make sure that my students understand these things over this period of time, or here's our strategy and our focus is on the U.S. manufacturing coming back, or what have you, you know, skills for the workforce, is that authentic view coming from the students themselves, where if you're writing this as students, you can say, here's what I'm looking to achieve, or my classmates and I are looking to do this, and these are the reasons why. Whoa, boy, if you can bring that voice through, I think, this is just my opinion, but I think that can give you some pretty high scores. Of course, you know, cross the T's and dot the I's, make sure you got your language well written. But it is kind of like an application. If you were going to go out and raise money, let's say you had a business and you're an entrepreneur, they invest in the people as much as they invest in the idea, right? And so if you think about this challenge, this proposal that you're submitting, they're going to want to see who are these folks and what are they up to, right? So I think it's really interesting to think about, and that can give you a leg up, because not every school is logging in to listen to this, is thinking about learning outcomes through the lens or through the view of the student. And of course, I think what also kind of helps reinforce that is if not only you look at it through the lens of the student, but you have that kind of narrative of a program that you have in place. So you have an absolutely amazing makerspace or a brand new facility you've set up, or you've reconfigured your shop, or you're raising funds to do that. By all means, talk that up too. But I think what's important here is we look through both of those lenses of the program as it exists, but also through the student's view, how the student can benefit, what they see as their learning outcome. Because I think at the end of the day, U.S. Department of Education is really looking for efficacy. You know, is this inspiring students to pursue aerospace or engineering careers, or perhaps investigations in the sciences? And so I think that's important to look at that. All right. Okay, so we've talked about community engagement and thinking about reaching out to the community, and not just, you know, with the, can you write a check to help us out, but thinking about earnest ways that your community can be involved in your project. And so you probably have some unique geographical features in your community, maybe sociographic components. Think about how you can tie those in to make your project unique for your community, whether it's in Louisiana, or whether it's in Ohio or New York, or wherever it might be. Your CTE connection, right? That what are you doing specifically in your school? How does that tie to it? And perhaps this is an inspiration to add something else that you would like to do, and now you can with that. We just talked about the learning outcomes, both through the lens of a program that you might have established, as well as through the eyes and ears of the students, which I think is really powerful and can definitely help your score. Okay, now here's where the rubber meets the road, as they say, right? This is the meat and potatoes. Mission feasibility, all right? So you want to run a gamma radiation sensor and an electron microscope, right? Inside your 1U CubeSat. Well, that's probably not going to happen. It sounds like a fantastic idea, but how long is that going to take to build? What's your testing protocols, et al, et cetera, et cetera. And so keep it simple. It's really, really, really easy to boil the ocean and say, I want to do all these things. I want 8 different cameras and I need a spectrometer on there and a radiation sensor. And so limit yourself. Feasibility. So the first thing is looking at the CubeSat standard. And what's great about this site that I'm sharing, everyone I'm sure is familiar with at this point, is the resource hub. Go through there and look at the different resources that are up there. And I will point out that this just came out in the publication, and I have to find out where it is on my site here, but no, that's not. It's a conference paper. It's batteries. It's around here somewhere. Darn it. I'll have to find it. It's a book that was just published by Dr. Ben Malfris out of Morehead State University. And Morehead State's out there in Kentucky, right, abutting the Appalachians, and you wouldn't think much of anything was happening up there. But they have a university aerospace program, and they have a 21-meter dish for the Deep Space Network. It's the first commercial dish on the Deep Space Network outside of like your typical Goldstone dish and what have you that NASA uses to track satellites in deep space. And so Professor Malfris just published his book, Cubesat Handbook. It's kind of expensive. It's like $200. You might be able to get it for 150 or 170 bucks. But if you want the nuts and bolts, that book literally was just published over the last week. And if you do your research under NASA and look at CubeSat, there's a lot of great resources. Both, I think JPL's got some great resources as well. Go to Cal Poly's, there in California is a co-inventor of the CubeSat. They've got some great resources. And in terms of feasibility, you're probably not going to get really deep into like your power budgets and this type of thing for this proposal. I think you would in phase 2 and further out if you actually intend to go to space. I'm just noting that there's some great resources that are out there. There are 2 major CubeSat conferences in the United States. One is in Cal Poly, usually in the spring around April, and it's called the Cubesat Workshop, and that's usually over 2 or 3 days. And what's beautiful there, it's the university students sharing their white papers about what they're about to do, what they're in the process of doing, or what they've just completed. And so it's like what's happening. And what's great is there's an archive going all the way back to like 2003 or something like that. And so you can read what everyone's done and looking at that. So it's unlikely you have something novel, but you may. But I would say, think about feasibility. What you really want to be able to do for this is to make sure US Department of Ed knows, based on your CTE components that you have, your community, what you've kind of built, your learning outcomes that you've set forward, that this group can actually do this thing, right? And so we actually have very simple instruments you can just kind of plug and play, and you can begin reading your environment, temp and humidity and barometric pressure and acceleration and magnetometer and things like that. And so if you just need something to plug and play, I think that's absolutely fantastic. And then beginning exploring what you might want to do with that, adding different sensors. So I'd say one primary mission, if you keep it real clear and direct, this is what you are interested in, and here's how we're going to research it. I think that's super critical. So, you create your hypothesis first, right? And from that, you make a claim, and then you kind of deliver that evidence through your actual flight, whether it's on-ground testing, kind of call it a flat set when you just have it all laid out and you're not actually flying it, just making sure all electronics works and what have you. And then your reasoning behind that evidence that you now believe that, above the ozone layer, you have a different radiation. At least you think that's going to happen. You've done your mission. Now post-flight, you can see it. And so, mission feasibility, I think, is super important. Don't get too fancy unless you guys are really, really already got this nailed down and you're doing crazy stuff, in which case I want to hear about it. Share with us what you're up to, because that's always fun. And if you really have your mission feasibility laid out for the idea of actually getting to space, if you don't know about CSLI, do look it up. It usually comes out in December. And this is a CubeSat launch initiative that NASA puts out. And you can actually write, and it's a much bigger document you're going to need to prepare. You're going to need to justify the science or the engineering or the educational component. But NASA, if they absolutely love what you're doing, they're going to give you a free ride to space. 1U, 2U, or maybe even a 3U satellite in orbit. And then you normally get deployed from a P-pod deployer right there off the space station into a slightly lower orbit. NanoRacks usually is the one that's distributing the CubeSats from that location. And wow, I mean, that's normally like $100,000. Well, I'll take a free ride. But that is a lot of work. And this, I think, if you're planning for it, can lay some good groundwork down. But mission feasibility, if you nail all these others and your mission feasibility doesn't make any sense, under normal circumstances, I think that would be a fail. Under the way that U.S. Department of Education is coming together, I think they're really looking at these other components as well. And I'm not suggesting you play that short at all. You really want to think through this, because I'm hoping that's really where the focus is your feasibility. And consider that when you run your first flight, that you're going to learn something. It's a tethered balloon. You've got it on the top of your building, and you're dropping off a parachute. Whatever you're doing in your tests, you will learn and you will adapt, and you can add more to it, right? So build on it, but start with your big idea, your big mission, and make sure that you can achieve that based on the budgets they're outlying and the time they've allocated. So $5,000 prize pool, you can do a lot with that. You definitely launch a couple balloons if you know what you're doing, if not more, or getting a high-powered rocket launcher too. It's a little on the low side for a suborbital, but who knows? We can probably talk to Blue Origin. If you guys don't know Erica Wagner over there, I'd be more than happy to make an introduction to Blue Origin. They just had a beautiful launch earlier, and it's just like SpaceX landing right back down there, the first stage landing and the capsule coming down under parachute. So a real successful launch for them today. So Mark, mission feasibility, make sure you really got that nailed. And if it's too complex, really ask yourself, is there a way we can do a gentler version of this, show that success, and then build on it? So, don't cram it with 25 instruments. You might overgo the mass, you might overgo your power budget, other things like that. Again, I'm not going to hold anyone back if they want to do it. I'm just cautioning that simplicity is usually a winner in these kind of formats. The fifth one, and there's one more, kind of a bonus one, but the fifth one is team composition. So, guys, gals, gender neutral, gender fluid, have a team that really represents your community, right? All colors, all races. Get some different perspectives. Hopefully you're not all just engineers or not all just scientists. Maybe you got an artist in your group. How awesome was that? If you can get this kind of multi-dimensional, transdisciplinary approach to this. If you look at taking your team composition, if you have a little dossier on your team members, that might be a super big positive thing. Imagine you guys are like the Avengers or the Justice League. What's your superpower? And why does your team come together and make the difference in the world? And why should you be funded? So I think your team composition, as I mentioned earlier, is like if you're going to go out and get funding for your venture capital backed startup, they're going to invest in the idea, in the people as much as in the idea. So keep that in mind. And I think that's really where you can make it shine. You guys know who you are. You know what you're up to, what really kind of motivates you and inspires you. Follow through on that and go ahead and put it out there a little bit. If you can tie the team composition into some of these other components, I think super important. Do you have a teammate that really is into social media? I mean, they are like bar none the best. Look at the engagement they have on the latest TikTok or the Instagram or whatever they got going on. Maybe you want to talk about community engagement and team composition and kind of tying that together and saying, I'm doing this kind of outreach with our community. So engineering, yes. Science, yes. But let's think about those other facets as well. Do you have an away team like in Star Trek in which you got everyone that you need? Just make sure no one's wearing a red shirt, right? You're going to be okay. I think that's really important to think about. And if you let that shine through a little bit, I think that's really important. Cut and dry, really to the book, very analytical is very helpful. But if there isn't any emotion there, if any humanity in your proposal, it may be overlooked, even though it's mechanically sound, engineering sound. They want to feel as much as they want to understand, if that makes sense to you guys. And that's true with most proposals, by the way, not to take away anything from the empirical, from the quantitative components of any kind of rubric, but there's a qualitative component as well. And that's an immeasurable quantity, but it can make the difference between getting it and not getting it. So keep that in mind too. Put a little flavor in there. Not ridiculous, you know, you can maybe be a little playful, or you can be very serious, but there's some tones there. You've got a multi-dimensional approach to your thinking. And as a team, you can come together. I imagine you can come up with some pretty good ideas. And then the other one I'll mention for those communities that have, you know, they're part of free and reduced lunch, that there is an added 5-point bonus for those groups. So if they're right on the edge, and the reason why the U.S. Department of Education has this in there is if you look just demographically speaking, communities of color, underserved communities, communities where free and reduced lunch is a requirement just because of the nature of income, rural communities, what have you, they generally have less technology available to them, less resources available to them. Their schools are generally older, right? And not like the brand new one that was just built. And so there's a 5-point bonus to that. And so if you're in a wealthier district, or you're in, you know, in a district that doesn't meet any of those criteria, you have to fight for those extra 5 points, right? So keep that in mind too. And I think it's an earnest way to think about a level playing field, which is important. But that means you're going to have to work that much harder, because these individuals that might be coming for those communities may not have the equipment and the support you guys have got. So keep that in mind. But you're going to have to make sure that you understand you're starting at essentially a 5-point deficit that you can't make up any other way other than getting as close to a perfect score as you can. And so I would say, kind of looking back through these 5 points, you're really competing against yourselves, right? As I mentioned, there are 2,500 schools that would qualify under the Perkins grant for this competition. As I understand it from Luminary Labs and from the U.S. Department of Education, only about 1 out of 10 actually submitted interest, so about 250. And of that, if the number is if it's kind of the same kind of orders of magnitude, then I would expect you're probably going to see 25 applications. And with 5 awards, you got a 20% chance of winning here, right? But you got to make sure you nail all these points. And I'm guessing, there might be 200 applicants, I don't know. But put your best foot forward, have it reviewed, have a third party review it. You know, have your parents look at it, have your teammates look at it, have your teacher kind of review it, have someone that's not even related to the group read through it and see if they understand it, especially with these more direct components like community engagement. So I kind of rattled through that in a quick 30 minutes, I guess faster than I thought I would. I can go back through that again, but I'd rather not belabor it. I can open it up now if you guys have got some questions. We can talk about the rubric as kind of what this hour was designed to do, but also if you just want to talk about CubeSats or about other missions that are more terrestrial in nature, why not? We can talk about that too. So the floor is everyone's here. And instead of chat, I think it's a small enough group to feel free to just go ahead and open up your mic, ask a question, and we can kind of just walk through it. We got some things in chat here. I was sharing my screen, so I didn't see it. Let's see. Can we include you or Magnitude as an organization we are working with? We are planning to have a large multidisciplinary team. How big is too big? Well, so 2 questions there. You want to make sure that we contact each other, all right, before you put us down as an organization we are working with. I might have reached out to some teams beforehand, but I've talked to a lot of folks. So do me the best favor and send me a note out. We probably want to try to find a chat for a quick 15 to 30 minutes. There's some that I already know, but let's just confirm that. And then what I can do is I can put a little letter of support in there, if you will, to that. But we do need to talk first, all right? And then what I'll do to kind of validate it, I'll provide a little letter of support that you can add as an appendix to your proposal. You know, there are things that we can help with, and there are things maybe we're not much help at all. You might have a really great program that's already in place, in which case I'll defer to your teachers and your program that you've got running. We're just trying to inspire as many students and teachers as we can, but we're more than happy to help out as well. Again, most of our stuff is done in orbit on the space station, but we love flying the balloons and the CubeSats in the simulated fashion. In terms of too big, think about jobs and responsibilities. If you've got half a dozen to a dozen, that's probably getting toward the max size there. Under a team of a half a dozen, you've got everyone that has one primary responsibility. Yeah, you can have a couple software engineers and a couple hardware engineers, but at a certain point, there's so many people can work around a device. So maybe you might want multiple devices. At which point, maybe you got 20 or 30 or 50 or 100. Maybe you want to actually put in a submission for 5 teams, right? Or 2 teams, and think about that. You've just done for your school, you've doubled your chances to win, right? Think about it that way. So if you actually have the capacity to break up and form 2 teams, why wouldn't you, right? What's important there, if you do that, is although there may be some similarities, you probably want to be distinctly different from team A if you're team B or team C, right? Which is to say your community engagement might be similar or might be underpinning everything, but really make sure that the other components are unique. And so I think that's pretty important. If everything looks the same except for the mission feasibility, they may go with the one mission and I'm not saying that they would, or I know how they're going to judge, but they may look at, oh, geez, this is identical except for the mission. We'll pick the best mission. And that might be the default. So make sure, I would say, to differentiate, play to your strengths and think about what those teams were designed to do. You got an all-girls team? Awesome, show it to them. I think they'll be really excited, right? You've got some other kind of team with a unique composition, by all means, bring that to the fore. You've got no engineers or scientists and you're all artists. Wow, that sounds pretty crazy. Let's talk about that, right? And I think those kind of differentiations, especially if you have mission feasibility nailed, then I think they're going to look kindly on your proposal. So let's see. Another question from Georgia. What are the pros and cons of an Arduino? Well, for prototyping here on Earth, not a problem at all. In fact, there is a company that was originally called Ardusat that launched a CubeSat in orbit, which was actually an Arduino. It was an Atmel chip, but it was basically running the C++ programming. So that's totally possible. A Raspberry Pi is a different device. If you've got, now you're dealing with a system on a chip. It's a computer. And you're now opening up some other kind of capabilities that you have there. You can even start looking at things like what can drive machine learning. Like your Arduino is going to turn things on and turn them off and run some conditional state stuff. Like if the temperature gets to this, do that. If barometric pressure goes here, do the other thing. And that's kind of what the Arduino is really designed to do, is just kind of set up logic control. From the standpoint of a Raspberry Pi, it can do that, but it also can do computation, right? So you could have a camera, for example, that was taking imaging. And if you ran something like TensorFlow Lite or something on your Raspberry Pi, you might be able to actually survey the images that you've taken, find just the best image according to your machine learning algorithm, and download that image. Wow, that would be pretty phenomenal. That's a lot of work. And if you're not actually in that field or haven't gone through it, you have to think about your mission feasibility. How feasible is it? How much power will it take, et cetera? I just kind of made that up extemporaneously, but that's something to consider. In terms of a prototype, the easiest we found is the Arduino. There are a lot of different Arduinos. We picked the Uno because it's near ubiquitous. I mean, the thing here is, just taking this thing apart. I mean, that's it. It's like you can get a knockoff for probably $5 or $10. If you get the one made in Italy, it's $25, $20, something like that. And that's just your chip right there, just an Atmel chip. And you got your pinouts, 3 volt, 3.3 or 5 volts, analog and digital. So you're really kind of set. And with that, you can do a lot of stuff. You can run servos and do robots with them as well. We just happen to add a shield on it with a bunch of different sensors so you're ready to fly. But, you can go out, spark fun, Adafruit. You can add, a lot of different things you want to do there. So if you want to do maybe rapid prototyping that's more sensor driven and kind of call and response, I'd say Arduino. If you want to do anything programmatic that maybe requires some state or maybe something like perhaps even like machine learning, then maybe look at something like the Pi. But in terms of flight readiness, if you needed to launch something, let's say, well, it just depends on your capabilities. I mean, depending on the team, we can have a number of different folks I know that are in high school that probably put something up this weekend if we said, let's do it. But you want to think through your feasibility and your long view too, right? Let's see, what should be included in the subsystem sketch? Go back to the resources hub and look up the different, let's see, subsystems tab here. I'm not sharing my site anymore, my page, but it's cameras. There are, the one I would probably recommend, I'm gonna need to send that link in an email follow-up to you guys. It's from NASA, and it's a CubeSat kind of state of the market. And it's showing, they measure instruments and TRL ratings, technology readiness level. And this is NASA putting together all the flight ready hardware. And what's great about that, and I probably have a document around here somewhere as I dig through my bin here, that kind of goes through the primary systems that I think you should recommend. Of course, it's going to be buried somewhere here. I'm not seeing it right off the top. But, you've got power, right? You've got your avionics. You've got your, command and control. So, these are kind of your basic components. But you check out your links on the resource hub. They're going to give you everything that you're going to want in it. Let's see. One second. How do you broadcast the signal from the CubeSat? Yeah, you if you can, it's very advised. So there are a lot of different ways you can do that. Our radios that we use an XB radio running 900 megahertz. And these little radios are great. This is a long range radio. This is called the XB Pro. And these things probably retail around 50 bucks. They're not cheap. But a pair of these, you have one connected to a Yagi antenna. Get the right kind of antenna. I got one here. Real simple antenna here is probably like 25 bucks or so. Point it right at your payload, and you can track this thing for miles. In a balloon, of course, it's going up. If it's a high altitude balloon, you're going to get up 19 miles or so, but it's also going downwind. So you might get the first hour in flight. Other options, look at and this is something Professor Twiggs talked about last Thursday, Global Star Radio, and there's other satellite radios you can get. You can put in a payload to fly. Data rates are not cheap, and the radios are not that cheap either. The radios are probably around 500 bucks or 350 bucks or something like that. But you're able to get, your telemetry will take from whatever you've got in a rocket or a balloon or whatever it is. It'll go out to 22,000 miles out in orbit. It'll take that data and then send it back to Earth again, and you've got near full coverage on the planet. So it doesn't matter where you launch your research from, you can get the tracking. You can probably use lo-fi also. I don't have a chip that I can recommend on that, but lo-fi is going to be small packets of data that you can travel over long distances. And then now here's the big win. If you can do this, and this will tie in with your career and technical education pathways, maybe just a text here, if anyone has it, your ham radio license, type in your call sign in the chat, okay? Because if you can show that you're using an amateur radio with your flight, wow, that's a big plus, especially if you tie it back into the framework of CTE and lessons learned. I think that's a really powerful thing you can do. If you haven't gotten your license, it's actually not that difficult. I mean, I got it, right? So, it's pretty easy. I just have the technician's license. There's the 3 levels, and that'll enable you to basically run a radio that'll enable you to travel long distance. We typically fly the APRS radio on every mission we fly. We use something like what's it called? It's called something tracker. But one of these trackers that you can just get at like an REI or a sports shop that you might put on your vehicle at your cabin or something in case someone takes your car or your boat. Your boat's moving. But we use it to track our payloads in near space. So a satellite tracker, APRS radio, and then something like XB, or you could look at lo-fi or something else like that. But comms is super important. Running a data card and capturing your data in situ on the flight is important. But you also got to make sure you get it back, right? So depending on your vehicle that you're using, then your flight mechanics. And I can talk to any team post-mission here, post-submission, if you guys are really earnest and you want to kind of figure out some different options, be more than happy to talk to you about that. See, does it matter if the sketch is hand-drawn or done in CAD? I would recommend computer-aided design if at all possible. If at all possible. It shows that you're working with the tools, right? Having said that, if you can have some inspiring sketches, that also is super important. The most important thing is you're conveying an idea, right? And if it's discernible, if you can call out sections, so maybe you hand draw something and you grab your notebook, you've hand drawn your illustration, draw some arrows to identify what someone's looking at, and some good, nice, it's not cursive and it's not scribble, but you can read that this is your power supply, and that type of thing. Then I think an illustration is perfectly fine. Colored illustration, sure, why not? A collage, but within reason here, I think a CAD is probably preferred. But if you have more of an artistic or creative bent in your group, I think that's all right as well, especially if there's some kind of inspiration behind it. And that's, looking for the unique. I think everyone looks at science and engineering, but if you can introduce a new perspective to this, a philosophical perspective, or maybe some fantastical one, and offers a new, I'm not going to say you get a higher or lower score, just take that into consideration. I think because this is a CTE mission, you probably want to lean more on and err more on the side of engineering practice, but just kind of putting those other elements out there. If it speaks to you, by all means, I wouldn't let it pass you by. Let's see, omnidirectional antenna mounted in our school, ground station composed of Raspberry Pi, radio dongle. Whoops, never mind. Okay, Georgia, you're describing everything to me and I got to the end. And all right, it sounds like you've already got your ground station, if I remember correctly. And there's some open source ground stations if you want to track satellites in orbit. You want to run RFM22B. I'm missing the model number, but there's a small radio transmitter that actually has gone aboard some satellites. And the thing is like $6. It's super cheap. And it's like, I think it's 900 megahertz, and you can track it on the ground, and they've been in satellites. So yeah, radio is pretty important. Think through your radio comms. If you look at this proposal though, you don't have to get too technical. You can just probably call it out. If you want to provide some more descriptions around that, that's important. If you want to play to your strength there, by all means do it. But keep in mind, if you put all your energy into the feasibility, make sure you're covering those other areas equally as well, right? Otherwise, they're going to say you're very strong in that, but what happened to community? You're very strong in that, but where is the connection to your CTE, et cetera? But I don't think you can go wrong talking about the engineering, but try to show a little multidimensionality if you can. I think in your best interest, it'll be a value to you and to your teammates. So I rattle on pretty quick there, don't I? Any other thoughts or questions? Ideas about the proposal? Is this something that you were expecting, or is there anything that I said that might be a surprise? I guess I'd be interested in knowing that. No? Well, great. All right. So I've just been rattling on. Usually it's better to have a little bit of a dialogue. I'm glad that's been helpful for you, Georgia, and for the others that have joined. And actually, I think I see Liam Kennedy. I know Liam. Hello, Mr. Kennedy. Now, Liam, since he's here, I'm going to go ahead and put him on the spotlight. Liam is a gentleman that, my gosh, you want to talk about astronomy, you want to talk about space, you want to talk about anything beyond Earth's atmosphere, this is the guy to talk to. Liam, good to see you, man.
Good to see you all, too.
This is our last video conference before the CTE mission CubeSat. And so we were just walking through the rubric and what's required to submit. And it really is more about a multifaceted approach rather than just an engineering approach.
Yeah, I loved everything you were sharing. There should be a TED presentation with TED.
TED Square.
You know what I mean? Sorry. That's not the first time that joke has been made, I'm sure. But yeah, no, just what you do for, bringing awareness to this, and, I really see this as being you mentoring the world out there and being a sort of cheerleader for what this can do. But yeah, but in real ways, I mean, your organization has always been a pathway to do, what this is all about. So I just loved being a fly on the wall
Well, there you go.
fly
No,
in
no.
space.
well, there you go. As long as you're not on someone's head, that's okay. Hey, so,
I didn't
hey,
even know I
so
was. Yeah, there you go.
yeah, I didn't
Cool.
want to go there, but I did. So there was actually an interesting question that you're much better suited to answer than me. And so Liam is an inventor of something is absolutely extraordinary. It was one running in his background there for a second. And it connects a live view of Earth from the International Space Station. And it has other really cool things as well. It has telemetry and what have you on it. It's an Internet of Things device, but he uses a Raspberry Pi.
Right. He knows everything about it.
He sure does. And
yeah, well,
if you were going to
thank
build a CubeSat, and you look at, let's say, like a microcontroller, like an Arduino, versus the Raspberry Pi system on a chip, what would you see some of those strengths are? You know, you're going to put this 1U or 3U up in orbit.
Yeah, I think you did a really good sort of representation of that in your own answer to that. So, you know, there's a place for everything. What I'm seeing more is that I'm hearing more examples where Raspberry Pis are being used for CubeSats that are actually in space.
Right.
So, you know, it seems to be happening more. And I think I don't know whether it's a choice of what you're more used to, or, you know, I know a lot of people, you want to have something plug and play. You want to have something that has been, you know, if you can, you don't necessarily want to reinvent the wheel. You want to use something that has been known to be used for the type of thing that you're doing. At least that's what a lot of space type work is. You know, it's around using something that's count-onable, reliable. And at the same time, you want to also be prepared to sort of break the rules, I guess, for the potential for something newer. And that's what CubeSats were, right? CubeSats were a total breaking of the barrier to get something into space or high altitude and those sorts of things. I like Raspberry Pis because, yeah, I have this thing going on that says I can do anything I want with them. And the only times I've broken down and used Arduino is if I really wanted to try something that was a little bit more ghetto. I'll call it ghetto. I don't know.
Oh, okay.
Something that was more, maybe lower functionality, but lower power, maybe more portable. So I have versions of my gizmos that were running off an ESP8266 platform. But generally, they're just a lot more contained and focused in what they can do. So, you know, I'm sure those.
Liam, would you recommend a beginner to start up with using Arduino Uno?
Yeah, I haven't. I've got to say that I'm probably not the best person to answer that question, because I found it, with my background in software side of things, I just really fell into the Raspberry Pi world like that. It was such an easy way of working, and there are so many tutorials to get you started and to plug hardware devices into the GPIO, do things in that world. So I found it personally very easy to do that. I've always, I've got to admit in the Arduino world, the development environments have always been a little bit more challenging for me to get working sort of like completely reliably. So that's sort of like, that's me. I'm sure it's not really endemic to the way that Arduinos work. So
there you go. Yeah, talking about hardware, there's so many different ways to go. I mean, I just got a new toy. I've got to actually activate this thing. This is the Nano Jetson, NVIDIA.
The FPGA.
Yeah, this is a big
thing. Wow.
Here, machine learning, right? If I can do it right there in situ, again, taking some observations, making predictions, sending that down. If I have a limited link budget, my radio comms. And keep in mind, that's the thing, when you're in orbit, you have to rely on ground stations to pick up your signal. And if you've got a direct, and this is what Liam's great at in terms of being able to track this stuff. But if it's directly overhead, what do you get, 12 or 15 minutes maybe?
Yeah, really, probably around 10 minutes, 11 minutes if you're lucky. Yeah,
and usually you're going to be low in the sky, right? Your angle's low, and you're not going to get that same kind of pickup. You might get 2 or 3 minutes. And so as your thing's going around, your satellite's going around the planet every 92 minutes or so, you might get it once or twice a day in which you're going to be able to grab a little bit of data. So is it going to try to get all the information you gathered over the last few revolutions around the planet, or just the best stuff?
Yeah.
So that's something to think about as well. And all of that, whether it's an Arduino or a Pi or like an NVIDIA, power budgets. You don't need to worry about them for the proposal. We're already kind of off on the deep end there, but once you take it to space and you start thinking about some of those requirements, you got thermal requirements also. And I guess I should mention that because someone asked about some things together to consider in your system. Whether you're going into deep space in the vacuum or whether you're in the stratosphere, you're going to deal with some extreme conditions. And so address those if you really want to get a little technical on the feasibility side. What are you doing to prevent your equipment from shutting down because it's a vacuum or because it's too cold? All right, so think about how you might insulate it. So there's some material science investigations there, some basic things you can probably look up and consider. What's interesting, when you're in orbit, you're going to be in a screaming, scorching hot 200 degrees Celsius for like 45 minutes. And you're in utter darkness, extremely cold, like minus 200 degrees Celsius for 45 minutes. And you have this twilight for a minute or two, and then it's like super hot again. It's not warming up. It's like, bump, super bright, hitting it with everything. And so your materials, as you look for solar panels and other things like that, will have to be able to handle that extreme expansion and contraction as that does it like a heartbeat every 45 minutes or so, right? And literally your equipment can just shake apart. If you actually get past phase 1 and past phase 2 and you're doing things like trying to submit an application under the Cubesat launch initiative with NASA, you're going to want to do thermal testing, right? And vibration testing. They call that shake and bake, right? You want to make sure that your stuff hangs together. Probably do some radiation testing for radiation hardening. Not too much of an issue in low Earth orbit. If you're over the poles, it's going to be an issue. And whenever you fly over the South Atlantic anomaly, you might run into some issues. And that's this opening in the magnetic field down east of Brazil, west of Africa. Down there, it's kind of a hole that opens and changes with our magnetic field. So, but generally in Leo, you don't need to worry too much about that. But I got off on the deep end there faster than I thought I was going to. So let me wrap back up here and see any final questions we have and keep us on track here. Let's see, do you think it would be beneficial to estimate total cost? I think if you look at feasibility, absolutely. If we're going to put on our logic hat, you're saying, here's all the things I want to do. How long will it take you and how much does it cost? And is the team capable of doing it? So you can cover that team capable of doing it under your team, team composition. But how long it will take and how much will it cost is super important. And I would say a budget it makes a lot of sense. It's not like you're trying to figure out how to spend $5,000 because they're just going to give it to you if you win. But you probably want to think about what it is costing and you're within reason. And so if you have any questions about that, you can let me know. Let's see. I guess that was a question that was just in there I missed earlier. Any other questions that you folks have here online? I gave you my email. Please feel free to use it over the next 72 hours. I will try to be as responsive as I can. Expect a late night for me or early morning, like first thing in the morning or evening. And if it looks like something that warrants a phone call, well, we can probably schedule a quick little call, like a 15-minute, max maybe 30-minute call to help you walk through whatever it is. Again, I don't know many of your teams. I would like to get to know them, so I can only probably offer some generalized perspectives. We work closely with a lot of school districts and educators really around the world. And so if you are interested in some of the more ambitious programs like running projects aboard the space station, Tony and I have got a robot going up there in 2022. Well, it's already up there, but we're going to actually be able to put something on it called AstroBee. Astrobi is a 30-centimeter cube free flyer that's on the space station. It's just now being commissioned. We're going to put a little digital nose on that baby, and he's going to sniff gases as it floats around the space station. It'll be pretty fun. And there's a robot arm and there's some other stuff that we're working on. But so there's a lot of cool things we can do when we think about career technical education in light of aerospace. And I'm really excited that you guys have logged on today to think about what might be possible as you prepare your proposal. So I think there's probably no better way to get involved than just writing this thing out, because they're not asking to demonstrate any physical thing, but that concept will be really important. So take the time, go through it. If you want us to review it, be more than happy to. We don't need to. If you need me to sign an NDA before I do that, consider it a friend DA. I probably won't be able to do that. So if you'd like to share, fine, but also understand if you want to keep it under wraps. But if you just have general questions, I'll be more than happy to answer those as well. And well, Frederick, thank you for jumping in. And I guess unless there are any other final questions, we'll wrap it up a couple minutes early today. So I'll just pause, take a deep breath. I'll actually let some oxygen into my body. All right, wonderful. Well, I will have this published so you can review it if you'd like, as well as sending you links to the session last Tuesday, as well as Thursday. And we have a little special we've just set up as well with the Arduino. If you want to run a sensor shield to just kind of get something going right away. Code's already been written, and it's a great building block to start from. So we did a special just because of this Cubesat challenge. We'll be posting probably the back end of today. It's not really anything that you need to worry about to get your proposal done. As you move through the school year, as you think about the winter, we should probably talk. Think in big terms here. You know, when you're off to college, what would you have done, right? And we're here to help you get that done, right? All right, guys. Well, thanks so much for joining me and Tony, and our special guest, Liam. Is great. I saw you there, man. I should have been looking earlier. Well, you guys have a wonderful afternoon or evening, and I hope to see and hear about your proposals here in the not too distant future. All right. All right. Take care now. Have a good evening. Bye-bye.
Bye-bye.